Hello guys, I am Enoch Blangat, and if you haven't subscribed to my YouTube channel, please do so, and don't forget to subscribe, like, and share. So I have a question here for you guys about joint moment generating function, which we all know or we understand as MGFs. So as you can see there, we have a question been told to consider three random variables x1, x2, and x3 having the joint BDFs. The function of x1, x2, and x3 equal to exponential negative x1, negative x2, negative x3, where it start from 0 to infinity. Xi is from 0 to infinity, 0 elsewhere, where I is 1, 2, 3, because we have three random variables, as you can see here. So the question is, find the joint moment generating functions and marginal MGFs, as well as the joint marginal MGFs. So we want to start by finding the MGF, joint MGF. So joint MGF is the MGF of everything here. So first, let's say solution. So MGF is D1, D2, D3 is the same or equal to expectation of exponential D1 x1 multiplied with D2 x2 multiplied with D3 x3, because this is a three random variable. So if you are following, so let us continue. So because of this one is a continuous function, so we integrate three times. So we have to integrate three times because we have three random variable. So we integrate from 0 to infinity, we double integrate from 0 to infinity, and we also integrate from 0 to infinity. Now we have been given, so the function is for us. We know this one is our MGF, so this one is our MGF. We multiply with, so we can say we integrate the function is MGF by dx1 we multiply with the function of x with respect to dx. So this one, our MGF need is what? So we say exponential d1 x1 exponential t2 x2 exponential t3 x3. We multiply with our function, which is exponential x1 x2 x3 with respect to tx1 dx2 dx3. You can see that's it. Now after that, we collect like times. So this to make work easier, we collect all x1 times. So we say we integrate from 0 to infinity exponential t1 x1. Because we have here, we multiply with exponential negative x1. This one is we integrate with respect to x1 and 0 to infinity of x2. This one is for x2 with respect to x2. We also integrate for the third time. This one is for x3. We are following, guys. If you are following, this one is negative 3 with respect to x3. That is it. Now we want only to operate on one side, because if we can operate this one, all of it are equal. So let us operate for this one. So we integrate from 0 to infinity exponential negative x into 1 t dx1. So this one is the same as 1 all over negative 1. This one is this one. When you differentiate this one, you are getting negative 1. When you differentiate one with respect to x, you will get negative 1. And also when you differentiate this one with respect to t, we are getting negative 1 also. So this one now will be 1 negative t that way exponential negative x 1 t infinity 0. So you are going to get, when you replace x with infinity, this one is 0. So because this one is 0, 0 multiplied with any number is 0. So it will be 0 minus, when you replace this one with 0, you are going to get 1. Exponential raised to 1 or raised to negative 0, you are going to get 1. So this one is 1 all over 1t. end up getting 1/1 the Azure MGF. So because we were asked about joint, hope you are seeing, we had been asked to find the joint MGF. So because of joint MGF, our joint MGF will be because this one is the same, we get so this is the right answer. Oh, if you write like this also you are right. If you write like this one, so you are right. This is right, guys. So that is it. That's it now for that one. Another question is we will have to find the marginal MGFs. So marginal MGFs marginal MGF is, if we want the marginal MGF of T1, we'll write T1, but D2 we replace with 0 and D3 we replace with 0. And we know our MGF because we had seen earlier our MGF was 1 minus T1, 1 minus T2, and 1 minus T3. Don't forget to use alternative 1. So because we want MGF or marginal MGF for T1, we replace T2 and T3 with zeros and we end up getting 1 minus T1 as our marginal MGF for T1. And marginal MGF for T2, we replace the remaining variables with zeros. We end up with 1 minus T2 raised to T1. Likewise, to marginal MGF for T3, we replace the other 2 with zeros and we end up getting 1 minus T3 as our marginal MGF. So these are now marginal MGF. So I think this is not such a difficult task. We can only solve this one after getting the joint MGFs. And the last question is for us to find the joint marginal MGFs. So we want to start by finding the marginal MGF of these two. we want to find joint MGF for T1 and T2, and earlier we had seen the marginal MGF of T1 and T2. So the only thing here is to multiply or to cross multiply this one and this one, so that you get this one. So this one you get you cross multiply with T1, T2. But for T3, you just replace with 0, and you are going to get 1. So when you get 1, you multiply with 1, everything here, you get 1. So this is the answer. And if you are asked to find for the joint marginal BTF for T1 and T3, so that means you replace T2 with 0, which you will end up getting T1 negative, and T2 you replace with 0, you get 1. So you say multiply with 1, you end up with the same thing. So this one you end up with this one. And the last is joint marginal for T2 and T3, which you end up with so these are now 3 joint marginal BTF that we can solve through joint moment generating function of the 3 random variable. So guys, thank you for watching. Please, if you haven't subscribed, please do so. And if you have any questions or any comment, please ask, and I will get back to you. And if there's a place you haven't understand, and there also to assist. Thank you for watching.